Hello and welcome to today's tutorial. In this video, we'll take a detailed step-by-step approach to creating a realistic 3D yogurt product in Blender. We'll be covering everything from modeling to texturing, animation, and rendering. By the end of this session, you'll have the skills to make your product animation look truly professional. Let's dive in. To begin, I'll be using a reference photo, which I've linked in the description for you to download. With Blender open, let's first clear the scene. Press A to select everything, then X to delete. Next, go into side view by pressing numpad 3. Now drag and drop the reference image into the viewport. If you're unable to do this, ensure that the Import Images Plane add-on is enabled in Preferences. To center the image, select it, press Shift+S and choose Selection to Origin. Then press G to grab the image along the Z-axis, aligning it properly with the Y-axis line. I'll also reduce the opacity to give us a clearer view while modeling. I will bring back along the X-axis a little bit. Let's begin creating our base shape. Press Shift+A to add a circle. Reduce the vertices to 24. Go into edit mode by pressing Tab and position it on the Z-axis to match the reference. Scale it until it aligns with the circular outline in the photo, then adjust along the Z-axis to fit the base shape. With the circle selected, press E to extrude and S to scale it along the Z-axis. Extrude once more, then press M to merge the vertices at the center. Now we'll start refining the shape. Select 3 outer faces and skip 1 face between each. Once selected, go into side view, extrude them along the Z-axis, then position it here, and switch to wireframe mode by pressing Shift+Z for easier alignment. Then press S to scale along the Z-axis to something like this. Now come here, then change the transform pivot point to individual origins and use S to scale, while pressing Shift+Z to snap along the Z-axis. Now select these faces, press S to scale them slightly, then grab and move them down along the Z-axis. Scale outward, then grab along the Z-axis again to create the desired shape. Next, press I to inset the faces. Inset again. Grab and move along the Z-axis, inset once more, and extrude downward along the Z-axis. Finally, inset the faces one more time to refine the shape. Now let's add bevels. Select these edges by holding Shift+Alt and pressing Ctrl+B to add 2 bevel segments. I will repeat this process on these edges to add a more polished look. Now let's continue to modeling other parts of the bottle. Just select these edge loops. With these edges selected, press E to extrude and scale along the Z-axis to match the shape in the reference image. I'll add a loop cut here by pressing Ctrl+R. Adjust the scale of this loop cut to refine the shape that we have in our reference. With these edges selected, press E to extrude and then scale along the Z-axis to match the proportions of the reference image. To ensure precision, I'll switch to side view and continue extruding along the Z-axis to here. I'll repeat the same process of extruding and scaling along the Z-axis, carefully molding the bottle shape to match the reference image. Now, after being satisfied with the shape, go to the modifier panel, add a subsurface modifier, and set the level to 3. Right-click, then shade smooth. Now it looks pretty nice. I will add a loop cut here to sharpen this edge slightly. Now that we've completed the modeling of the bottle base, let's move on to creating the bottle thread, which will add a realistic touch for when the cap is opened. To begin, enter Edit mode and select the middle vertices. Switch to Top View to ensure you're selecting only the center vertices accurately. With this vertice selected, press Shift+D to duplicate them and place the duplicate at the top, where we'll start the bottle thread. Then press P and choose Separate by Selection. For this demonstration, we won't be using precise measurements for the bottle thread, as our focus is on creating a visually clear representation. Select the vertices again, and for better visibility, I'll temporarily disable the subsurface modifier in the viewport. With the vertices selected, enter Edit mode, then extrude slightly along the Z-axis. Press Ctrl+R to add a cut here. With the new vertices selected, press Ctrl+Shift+B to bevel them slightly, creating some spacing. Add another vertex cut here at the middle, and bevel again. Bright them close to those vertices here. Now, with these vertices selected, press G to move them along the Y-axis and scale along the Z-axis to achieve the basic thread shape. Next, go into Object mode and open the Modifier panel. Add a screw modifier to create the spiral effect of the thread. Set the iteration to 2 and adjust the screw value to around 0.074. Increase the step count to 24 to match our bottle's base shape. Apply the screw modifier. In the Edit mode, select all, then press Shift+N to recalculate the normal. You may notice that the vertices aren't fully connected when you enter Edit mode. To fix this, add a weld modifier. Adjust the distance value until the edges connect smoothly. Once the edges are properly joined, you can apply the weld modifier. Next, switch to Face mode and select these faces here. Then press X to delete them. Hold Alt+Shift and double-click to select the edge loop, then deselect these edges here. I'll repeat this for the bottom vertex as well. With the edges selected, extrude and scale along the Z-axis. I'll select the top edges, press S to scale, snap along the Z-axis, and enter 0 to flatten. I'll bring these edges down slightly for better alignment. Repeat the same steps for the bottom edges. Before finishing the thread, enable Auto Merge Vertices here to simplify edge connection. Press Ctrl+R to add a loop cut and position it here, aligning it with this edge. Now, as I move these vertices, you'll see they're automatically connected. I'll select a vertex, go to the Snap options, switch to Vertex, then press G and hold Ctrl to snap it to this vertex. Select the face, press I to inset it, and align along the Z-axis for accuracy. Next, select this face and press X to delete it. Grab and snap each vertex to its corresponding location for clean alignment. Select the face again, extrude, and snap to this edge for better alignment, then delete this face and select these vertices and snap to this vertex. Now, select these vertices and press G twice to slide the vertices to have a shape like this. I will fix the shading to have a clear view of our mesh. Right-click, then shade flat. Now just repeat the same procedures for this part as we did before. Moving into side view, press A to select all vertices, then grab down along the Z-axis and scale slightly. Now, I'll select the bottom vertices, press E to extrude. Adjust the shape using proportions similar to the real bottle to achieve a more accurate look. I'll add a loop cut here and scroll with the middle mouse to add 2 cuts. With the new vertices selected, press Alt+E to extrude faces along their normals and pull them out to create this shape. I'll then adjust the edges slightly to refine the look of the bottle thread. Now, let's add thickness to the bottle. Select the body of the bottle and temporarily disable the subsurface modifier in the viewport for better performance. Right-click and choose Shade Flat. Then go to the modifier panel and add a Solidify modifier. I'll set the thickness to 0.01 and uncheck Fill. Apply the Solidify modifier. Then select the main body of the bottle, hold Shift and select the neck, and press Ctrl+J to join them into a single mesh. Back in edit mode, select these edges, then press Ctrl+E and use Bridge Edge Loops to connect them. Next, select the top edge, extrude up slightly, and in top view, extrude and scale it to match the thickness of the main mesh. With the top edge selected, hold Shift to select these edges, then bridge the edge loops to connect them. Now, I'll enable the subsurface modifier in the viewport again. It's looking pretty good, but I'll add some support loops to bring in slight sharpening along the edges. After making a few adjustments to the thread shape, we're ready to model the bottle cap. First, disable the subsurface modifier in the viewport and set the shading to flat. I'll add a loop cut here to find the accurate center between these edges. Select this vertex, hold Ctrl, and select this vertex. With both vertices selected, press Shift+D to duplicate, and then P to separate them by selection. Next, I'll dissolve the loop cut we added as a reference. Select the edges and press Ctrl+X to dissolve them. Now, select this edge, go into edit mode, and dissolve these vertices to optimize the mesh. We'll follow the same process as before by using the screw modifier. For easier visibility, press / to enter isolation mode, providing more space for modeling. Once you've finished modeling the shape, press / again to exit isolation mode. Move the shape slightly along the Z-axis and rotate it to align correctly with the bottle thread. Select the top vertices, extrude them to start filling in the bottle cap, then extrude again and scale inward. For the final vertices, press M and choose Merge at Center. Select these faces and extrude down along the Z-axis. I'll add a 2-segment bevel to the edges here to reduce sharpness. Next, select the bottom vertices. Extrude to this point, extrude again, then scale out slightly. Extrude once more and move the vertices to the top along the Z-axis and ensure a nice thickness for the cap. Fill the area by merging vertices at the center. Let's add the collar. Select these faces, duplicate them, and move them down slightly along the Z-axis. With these faces selected, extrude and grab along the Z-axis to reach this point. I'll refine the shape to achieve a smoother result. Adding a 2-segment bevel to the edges will help create softer edges when we apply the subsurface modifier. Now enable subsurface modifier in the viewport. If you notice incorrect normal, you can see the normal of your object by enabling face orientation in the viewport overlays. To fix it, in edit mode, press A to select all, then Shift+N to recalculate the normal. Now, let's add ridges to the cap. Select the cap, press Ctrl+L to select all linked elements, then separate it by selection. Set the subsurface modifier level to 2 for this cap and apply it. Select the unnecessary vertices and press Ctrl+X to dissolve them to optimize the geometry further. Select these faces, press I to inset slightly, then press Alt+S to scale outward and achieve this shape. I'll add a loop cut and apply a bevel for smooth edges, setting the subsurface modifier to 1 level on this mesh. With modeling completed, we can now delete the reference photo. Now that the bottle model looks great, let's move on to UV unwrapping and adding textures. We'll place the bottle label here, starting from this section and covering down to the bottom. I also want the inner part of the bottle to have a white color that flows from this point down to the inside. The cap will match the main color of the label. To make UV unwrapping easier, let's assign a vertex group for the label area. This will allow us to add and adjust the label independently. First, go into Edit and select a face in the area where the label will be placed. Then, press Ctrl plus Numpad plus to expand the selection up to this section. Next, go to Object Data Properties, click the plus button to add a vertex group, and click Assign to assign this selection to the new group. I'll rename this group to Label for easy reference. Now let's mark seams to where we want the label to be placed to make UV unwrapping simpler. With the faces selected, press Ctrl+I to invert the selection, and then press H to hide the selected parts so we can clearly focus on these faces. I'll select these edge loops here, then this top edge loop. For this bottom part, I'll deselect these edges along the sides, then select these edges here. With those edges selected, right-click and choose Mark Seam. Now, press Alt+H to unhide the rest of the part. Switch to the shading workspace so we can start adding textures and materials. Click here to add new material. For the label, I'll use this image, which you can download from the link in the description. I'll name this material white. This will be the main material for the inside of the bottle. To apply the label material, go back to Object Data Properties, select the Label Vertex group, then switch to Material Properties. Click the plus button to add a new material slot, select the new material, and click Assign to apply it to the selected faces only. I'll rename this material to Label for easy reference. You can see that changing the label material's color affects only the faces we selected for it, giving us full control over the label appearance without impacting the rest of the bottle. Let's add the label image to the bottle to display the brand and product information. First, ensure that Node Wrangler is enabled in Blender's preferences. This add-on makes it easier to manage texture nodes. Go to Edit, Preferences, then Add-ons, search for Node Wrangler, and check the box to enable it. Now, press Shift+A in the shader editor to add an image texture node. Click Open to locate the image file for the label and load it. With the image texture node selected, press Ctrl+T to add the texture coordinate and mapping nodes. Now connect the color output of the image texture node to the base color input of the principled BSDF shader. At this stage, you might see a black color on the label area. We'll fix that with UV unwrapping. Go into Edit mode and select the area we previously assigned for the label in Object Data Properties. Press U and choose Unwrap. Now the label should appear on the bottle, though it might need further alignment. Switch over to the UV editing workspace and set the viewport to Material Preview to see the label as you work. In the UV editor, select the vertices linked to the label by pressing L over any part of the UV island. For better alignment, use the UV Squares add-on if you have it enabled. Press N to open the side panel in the UV editor and go to UV Squares, then click Grid by Shape. Now, grab and scale the UV island so that the label fits well on the bottle. Once it looks good, go back to the shading workspace for further adjustments to the material. Add a color ramp node, drag the factor handle, then add a noise texture node. We'll start by linking the mapping node output to the vector input of the noise texture node. Then, connect the color ramp output to the roughness input on the principled BSDF shader. Adjusting the color ramp handles will let you increase or decrease roughness, giving the surface a more glossy effect. To see these adjustments in real time, select the noise texture node, then press Ctrl plus Shift plus left click to activate the node preview function. With the noise texture in view, increase the scale and detail to add finer texture variations. Try experimenting with these values to achieve the ideal surface roughness for a realistic look. Next, we'll add a bit of depth to the bottle by introducing bump mapping. Add a bump node along with another noise texture node. Connect the texture coordinate node, switching from generated to UV coordinates. Link the color output of the noise texture to the height input of the bump node and connect the normal output of the bump node to the normal input on the principled BSDF shader. Adjust the strength of the bump node to set how pronounced the texture is. To add realism, continue tweaking the scale and detail values of the noise texture for a more authentic appearance. Now it looks great, but let's refine the surface with a light coat. This adds a polished effect. Try to use a small value to have a little bit of polish on the surface. Now, let's move on to the white-colored section of the bottle. Switch to isolation mode to focus on this area. Select the white texture. For this one, I will use the same method as we did before. The difference is that the base color will be white. Feel free to explore different values until the texture feels just right. Now go out of isolation mode. Now let's complete the bottle by texturing the cap. For simplicity, we'll use a basic color that matches the main label, which in this case is blue. Adjust the roughness settings to give the surface a realistic plastic texture. If you'd like, you can repeat the previous texture and bump mapping techniques to add detail to the cap. With the texturing complete, we'll move on to lighting and setting up a backdrop to bring the final render to life. First, I'll set the dimensions of the bottle to match the real size of a yogurt bottle, ensuring accuracy in the animation and lighting. I'll select the bottle, set the transform pivot point to the 3D cursor, and press S to scale while monitoring the dimension values. I'll scale the bottle until its height is approximately 0.59 meters, matching the intended size. Before adding the backdrop, I have created a duplicate of the bottle and applied a different label texture to introduce variation in the scene. Next, I'll create a backdrop for the animation. I'll add a plane to the scene and scale it to cover the scene. I'll select the back edge of the plane, extrude it upwards along the Z-axis, and then select this edge and apply a bevel to smooth out the sharp corner by pressing Ctrl plus B. For additional refinement, I'll press Ctrl plus 2 to apply 2 levels of subdivision. Then right-click and select Shade Smooth for a polished look. With some additional adjustments to the edges, the backdrop will have a clean look. Once the backdrop is ready, I'll switch to the animation window. Add a camera to the scene. With the camera selected, press Alt+R to reset its rotation and rotate it 90 degrees along the X-axis. In this window, I'll switch to the camera view using numpad 0, adjust its position by moving it back and slightly along the Z-axis, and frame the bottle nicely. In the camera's object properties, I'll increase the Passepartout value to 1 for a better view of the scene. I'll switch this window to Material Preview mode. Before starting the animation, I'll parent the cap to the bottle by selecting the cap, holding Shift, selecting the bottle, and pressing Ctrl+P. This ensures the cap moves along with the bottle. For the animation, I want the bottles to come into the scene from opposite directions. I'll switch to the top view, select this bottle, and set X position to 0, then move it along the Y-axis. Just do the same to this other bottle and put them together here. I'll set the end frame to 80 and go to frame 1. But before I start adding keyframes, I have to change the rotation of the bottle along the Z-axis to add a different direction of the label for better animation. Select the bottle, then press I to add location and rotation keyframes. Then go to frame 50, move the bottle along the X-axis to around -1.2, and adjust the rotation so that the labels face the camera. I'll add location and rotation keyframes here as well. I will repeat the same procedures for this second bottle by adding the rotation and location keyframe. To make the animation smoother, I will switch this window to the graph editor, then in the graph editor expand the object transforms and then lock all the transformations. I'll unlock the X location, press the period key, then select frame selected or frame all to zoom closer to the selected graph. I'll select this handle, right-click, and change the handle types to free. For the shortcut, press V and drag the handles to create a smooth speed up and slow down effect. As you can see, the animation starts at speed and is going to slow down at the end. I will repeat the same process for the Z rotation. Just grab the handle and adjust it to create a shape like this. Next, I'll add a slight rotation along the X-axis to enhance the animation. To do this, I'll select the X rotation, unlock it, then select the first keyframe and grab it downward to add a subtle rotation to the bottle for a smoother and more polished look. I'll follow the same steps for this second bottle. Now that I'm satisfied with how it looks, let's add some camera animation. First, select the camera and go to frame 50. Press I to insert a location and rotation keyframe. Next, go back to the first frame, move the camera closer to the bottle, and press I again to add another location and rotation keyframe. I'll refine the camera's movement in the graph editor, applying the same adjustments we used for the bottle to make it start at speed and slow down. Select the Y location in the graph editor, change the handle type to free, and adjust it down to have this shape. Now it's looking great. I'll add a slight rotation at the start to enhance the overall appearance. To do this, go to Y rotation in the graph editor. Select the first handles and slightly adjust them along the Y-axis to add a subtle rotation. Ensure you're on the first frame while making these adjustments. I'll repeat the same steps for the other handle to create a shape like this for a smooth and polished effect. Now, let's begin adding lighting to our scene. First, I'll adjust the render properties by changing the render engine to cycles. If you have a GPU, I recommend using it for faster rendering, but if not, you can leave it set to CPU. Next, switch this window to render mode so we can preview the results as we add the lights. To have full control over the lighting, I'll set the world strength to 0, this allowing us to create a custom light setup. Press Shift+A and add an area light. Move it along the Z-axis to place it above the scene. Scale the light slightly and increase its power to brighten the scene. With the area light still selected, press Shift+D to duplicate it. Rotate it and position it to this side of the scene. Adjust its size and power to balance the lighting. Duplicate the light again and place it on the opposite side. Then, duplicate one more light. Position it in front of the bottle and rotate it slightly to add focused illumination to the bottle's front. Currently, the back of the scene lacks sufficient light. Duplicate this light and move it to the back of the scene. Scale it along the X-axis to create a broader light source, ensuring the back is well lit. Now it's looking nice. If you prefer, you can experiment with the color of the backdrop to give the scene a unique appearance. For this tutorial, I'll keep it simple and stick with a white backdrop for a clean and professional look. However, feel free to try different colors or gradients to achieve the style that best fits your vision. For the finishing touches, I'll add depth of field to the camera and set the focus target to one of the bottles. I'll adjust the f-stop value to get the desired blur effect. Now, go to the render settings and set the maximum samples to 300 for better quality. Enable motion blur to make the animation smoother, and in the color management section, change the look to medium-high contrast to enhance the scene's visual appeal. Next, go to the output settings, select the output folder, and for the file format, I recommend using PNG to render the frames as a sequence of images. Once everything is set up correctly, you can click Render to start the animation, or simply press Ctrl plus F12 to begin rendering the animation. And here is the result after adjusting the color correction. That's it for this tutorial. In the upcoming video, I will show you how to create more animation scenes using this product. I hope you've enjoyed it and learned something valuable. If you did, don't forget to like and subscribe. See you in the next video.